All right, good morning, 8th grade math students at Rainey. In this video, we're going to do the answers to the lesson 9.1 to 9.3 review. A reminder that this is our last quiz of the school year. There's only 15 days left. If you do want to retake this quiz, it must be done before we take our unit test, which will be on May 26th. So without further ado, let's go ahead and get started with number 1. It says, are the two figures congruent? If so, describe a sequence, blah, 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 blah. If not, why are they not congruent, right? So, first thing you need to do, you take your patty paper, and you have to trace ABC. Now, unfortunately, my iPad will not allow me to trace and show you on patty paper, so trust me when I tell you that when I traced ABC and I tried connecting it to XYZ, they were both the same. They were the same shape, same size. So first, yes, this one is congruent. Okay, so that's step one. The second step is, if they are, then what sequence of transformation maps ABC onto XYZ? So I like to put a 1 on the ABC and a 2 on the XYZ because they're saying, how do you go from ABC to the XYZ, right? So the first thing I did is I did a reflection on the x-axis, okay? So when you do a reflection on the x-axis, right, then this will essentially now be here, and it will look something like that. Again, I wish I had patty paper, but I don't, so I'm going to make it work, right? So it looks like that, and clearly it's not on 2 yet. So the first one, reflection on the x-axis, right? And then now I just have to move it to the left. So when you're just sliding or moving something in one direction, that's called a translation. And after you do a translation, all you have to do is to go 8 units. And then in this case to the left. So bada bing, bada boom. That is how you do numero uno. Alright, so for number 2, it says, are the two figures congruent? If so, blah, 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 blah. Same exact type of question, right? So again, use your patty paper, okay? And ABC is the first one. DEF is the second one. And then Jeremy is going to tell us out loud here whether they are congruent or not. Go ahead, Jeremy.
They're not congruent.
Why?
Because they're not the same shape.
Well, they're the same shape. They're both triangles. They're not the same size, right? So if you notice ABC, the longest part is 1, 2, 3, 4 units long, right? The longest part on DEF is going to be, doesn't matter because it's a same side all the way around. This one's only 3. So there's no way that it has the same size. So we're just going to put not congruent because of its size. Boom. Done deal. And again, use patty paper, because if you don't believe me, just put patty paper and you'll notice that they don't match up. All right, number 3, it says triangle RST is congruent. Now notice, they are congruent. They're already telling us that they're congruent. You're not being asked, are they congruent? They're telling you they are congruent. They have the same shape, same size. So there's no need for you to check to see if they're the same shape or the same size. But they do want to know, how do you go from RST? So we're going to call this one number 1, because they're telling us, how do you go from RST to UVW? So how do you go from the first triangle to the second triangle? Okay. Now again, patty paper is going to be your best friend. Okay. So if you try to rotate it, if you try to do a translation, you're going to notice that you're going to have to flip your triangle. So whenever you flip your graph or your patty paper, right? First of all, that's going to be called a reflection. So that's the first thing you're going to need to do, a reflection. And in this case, we're going to do a reflection across the y-axis. Okay? When you do a reflection across the y-axis, it's basically just bringing, and let me do this in another color, because if not, you guys are going to complain. It's going to bring it over here, 4 units, so it's going to look like this. Oops. I screwed up on the, should go inwards. There you go, like that. Okay? So that's the first one. There's a reflection. Clearly the blue triangle that I just drew, that's my reflection, does not line up with the number 2 triangle. So then after that, you have to do a translation to the left 2 and then up 4. So the second sequence is to do a translation. You have to use the words that we gave you. The words are reflection, translation, dilation, and rotation. You can't just say move it left 2 and up 4. You got to say translation, left 2, up 4. For number 4, it says, what transformations could be used if trapezoid A is the preimage and trapezoid B is the image? Are the two figures congruent? So again, use your patty paper first and foremost. You are going to trace A. And then after you trace A, then try to see if you are able to move it onto B and if it's the same shape and the same size. Okay, so first, are they congruent? Yes, they are congruent. So I'm going to put yes, congruent. That's the first thing. Okay. And then they want to know, if you take your patty paper, what is the only way to get your A to line up with your B? The only thing you can do for this one, ladies and gentlemen, is a rotation of 180 degrees. Once again, it does not matter if you say clockwise or counterclockwise, because 180 degrees is 180 degrees. Okay? It's like jumping halfway. If you're starting at the front and going to the back, it doesn't matter if you jump left or you jump right. You're still going to end up at the same spot. So rotation of 180 degrees. All right. And here we go. 6th grade material. This one should have been the easiest for all of you. So you'll notice on this first one, I'll highlight it. Okay. That one says angle A. That is the universal symbol for angle A, right? And so if I look at angle A, it only has one arc. So then I look at the second triangle and then I ask myself, which one only has one arc? Oh, there we go, angle D. So this one's angle D, this one is angle E, because I'm not going to go over it. This should be pretty self-explanatory. And then in regards to the side lengths, you just look at the tick marks. So for example, AB only has one tick mark. So the only other one that has one tick mark, I don't care if you put ED or DE. Mr. Rogers may care. I don't care, since Mr. Rogers students are watching this. I could care less if you go in alphabetical order or not. I just care that it's the right side length. So those are your answers for number 5. All right, for number 6, there's a typo. My bad. Our bad. Okay? I blame it on Mr. Rogers, but then I blame it on me for not catching it. This should not say AB, because some of you guys are probably like, what the heck? Where is AB? This should say FG. Okay? So, BCE is congruent. How do I know it's congruent? There's a symbol for congruent. It means it has the same shape and the same size. Okay? It says if the length of CE, so if this length here is 14, they want to know what is the length of FG. Well, as long as you know that this is a reflection, okay, the E matches with the G, the C matches with the F, the B matches with the D, and more importantly, CE matches with FG. So in this case, your answer is just simply 14 inches. Easy. All right, so for the backside, ladies and gentlemen, it says, are the two figures similar? Okay, now notice we're not using congruent. Excuse me. Congruent means same shape, same size. Okay, Similar means same shape, not necessarily the same size. So if you notice, number 7, right? One triangle is bigger than another triangle. Okay, that's very obvious here. So don't think of congruency, because some of you guys probably wrote, no, it's not, because you were thinking we were talking about congruency, and we're not talking about whether it's congruent or not. We're talking about whether it's similar or not. So how can we tell if something is similar? We have to look to see if it has the same scale factor. Okay, so for example, right, this, right, CB is the base of the triangle. If I were to flip it upside down, that would be the bottom part of the triangle, right? So this part, sorry, let me go back a little bit. I got ahead of myself. So they want us to know, how do you go from ABC to DEF? So how do you go from number 1, ABC, to number 2, DEF, right? Whenever we are doing these, always start with the second triangle first. Always start with the second shape. In this case, it's a triangle. So if I look at the base, the bottom part, that's from F to E. So if I do FE, I compare that with the corresponding part of the first triangle, which in this case happens to be CB. So FE is 3, CB is 6. If you want to simplify, it simplifies to 1/2. Now, some of you guys do not like fractions, and I don't blame you. So if you want to simplify this, this would be a 0.5, okay? And if you think about it, 0.5, is that a number less than 1? Yes, it is. That means that your second triangle has to be getting smaller, and in this case, it is, so we know we're good. If you did it opposite, if you put the 6 on top and the 3 on the bottom, that is technically wrong. Why? Because the triangle's not getting 2 times bigger, okay? It's getting 2 times smaller. It's getting half of the size. So please make sure that whenever it says you have to map one triangle onto the other, you always put a 1 and a 2. Always put a 2 on the second triangle, so you know to use those side lengths first, okay? Now, if this is similar, then the rest of the scale factors also have to be 1/2 or 0.5. So for example, I'm going to do the height of the second triangle. That's going to be DE. The height of the first triangle is AB. DE is a 3. BA is a 6. And once again, you'll notice I get 1/2 or 0.5. So as long as I do the last one, and it also gives me a scale factor of 0.5, then I'm good. So for the last one, I look at the hypotenuse, right? The hypotenuse, you just count the diagonals of the squares. That's typically not the way you do it. You're supposed to do Pythagorean's theorem. But in this case, we made it nice and easy for you guys, okay? So from F to D, we compare that to AC or CA. It really doesn't matter. So this also is 3/6, which is 1/2, which is 0.5. So you'll notice all of my scale factors are 0.5. Okay? So when it says, are the two figures similar, we have to put yes, similar. You guys can put this at the very bottom, but as you can see, I kind of ran out of space because I zoomed in on my pictures. And then it says, how do you go from 1 to 2? So first, we had to do a dilation. The reason why we do the scale factors is because in order for us to say that it was dilated 1/2 or 0.5, we couldn't have done that without using my side lengths. So you could put dilation of 1/2 or 0.5, either one. And if you make number 1 half of the size of number 2, the second thing you would have to do is a reflection across the x-axis. So if you take the coordinate points from A, B, C, and you make them half the size, okay, then the only other way to make the first triangle map onto the second triangle is by doing a reflection across the x-axis. All right, for question number 8, once again, are the two figures similar? And then if so, you're going to describe the transformation. If not, explain why. Okay, so we're trying to go from A, B, C, D, so this one, number 1, onto E, F, G, H, which is this one, number 2, right? So the rectangle is getting bigger, so my scale factor has to be a number greater than 1. Same thing as I did with the previous problem, you're just going to match up parts. So for example, F to G, we'll call that the height of the second rectangle. I compare that to the other height, which in this case would be the BC. From F to G, it is 3. From B to C, it is 2. When you do 3 divided by 2, you get 1.5. As long as the other scale factors are 1.5, then we are good. Okay, so now I'm going to compare, let's say, for example, DC. And I'm going to compare that to HG. Always start with the second one first. So in this case, the HG goes first. Compare that to DC. From H to G, that is a 7. From D to C, that is a 5. And 7 divided by 5 gives us a 1.4. Okay? Now, if you notice, look at my scale factors, right? The first one was a 1.5. This is a 1.4. Are those scale factors the same? Bato's nodding his head in the back saying no, and I agree with him. So we say not, I was going to say no, not similar, but I'd rather say not similar. So not similar. And then why? Scale factors not the same. That's it. That's all you have to write. It's not similar because the scale factors are not the same. Okay, so for number 9, it says trapezoid EFGH is similar. They're not asking you, are they similar? They're telling you they are similar. Okay? And it says, determine the set of transformation that maps EFGH onto MNOH. So EFGH, we're going to put a number 1. They're asking us, how do I get to number 2, right? So first, obviously, they're not the same size, so we have to figure out the scale factor. How do we go from 1 to 2? Because it's getting bigger, that's called an enlargement, okay? We are going to have to figure out the scale factor. So you only choose one thing to compare. I'm going to choose this part, ON, and the same part is FG. So over here off to the side, I'm going to put ON, compare that to FG. ON is 4 spaces, FG is only 2 spaces, 4 divided by 2 is 2. So there's my scale factor, right? So first, I'm going to put dilation of 2. 2 tells me that it is getting 2 times bigger, so that's how I'm going from the small image to the big image, or the small trapezoid to the big trapezoid, okay? Now, after I make number 1 2 times bigger, right, notice that I have to do something in order for them to match. The only other thing that you have to do for them to match is you have to do a reflection across the x-axis. Okay? So after you make 1 into the same size as 2, then you have to do a reflection across the x-axis in order for them to match up. So there's your answer for number 9. Last but not least, number 10. A t-shirt iron-on measures 2 by 1 inch, as you can see in this picture. It is enlarged by a scale factor of 3 to be placed on the back of the shirt. So let's start by doing this. The original image is a 2 by 1. We're going to call this the original. And then it says it is enlarged by a scale factor of 3. So in other words, sorry, bell's going off. We take the original image and we multiply both things by 3 because that's my scale factor. So the new image, 2 times 3 gives you a 6. 1 times 3 gives you a 3. So this is the new image given the scale factor of 3, right? And then it says, then this second iron-on, so now they're talking about this second iron-on, which is this one right here that I've done in purple. This second iron-on is enlarged by a scale factor of 2. So now they want to multiply the one in purple by 2, right? And in this case, it now becomes a 12 by 6. All I did is I multiplied the 6 times the 2, the 3 times the 2. That's how I got the 6. And I multiplied this by a scale factor of 2. So I put SF, scale factor of 2. It says, what are the dimensions of the largest iron-on? So they want to know, what are the dimensions of the largest one? I'm going to do it in blue, so that way you can see it. So here are the dimensions. So there's your first answer in blue. And then they want to know, are both of the enlarged iron-ons similar to the original? Now remember, similar means that they have to have the same scale factor. Now notice that the second image had a scale factor of 3, the third image had a scale factor of 2. Because they have different scale factors, the answer is going to be no, not similar due to different scale factors. And that's it. That's all you need to do for the last question. Make sure you guys study. Again, quiz is tomorrow. Quizzes are retakeable, but please make sure that you look at this video plenty of times. If you need to, cover up your answers. Do it on a scratch sheet of paper to see if you know how to do it. Other than that, peace out, my dudes. We'll see you guys mañana.